In the vast universe, among billions of stars and hundreds of billions of planets, a challenging question has always haunted humanity. Is there any intelligent life beyond our blue planet? This is not just a dream or a fictional idea, but a question that modern science is striving to answer. Today, we will explore the endless possibilities of intelligent life on other planets and the new advancements in this journey. In the past, we have delved into the Fermi paradox, an intriguing contradiction between the high probability of the existence of extraterrestrial civilizations and the absence of evidence or communication from these civilizations. However, today we will shift our perspective. Instead of merely questioning the existence of intelligent life, we will examine the methods we can apply to bridge the vast cosmic distances in our search for these civilizations. We will explore emerging technologies and theoretical pathways that may allow humanity to venture beyond our planet to explore the stars. Imagine a scene one day. Humans set foot on a distant planet, becoming the aliens we have long sought to find. This idea not only excites us, but also changes our perception of our place in the universe, highlighting the first steps we are preparing to take to make interstellar travel a reality. While our search for life beyond Earth in our solar system progresses, we are beginning to pursue more practical possibilities. Geographically speaking, although searching for intelligent life in our celestial neighborhood may seem far-fetched, there is hope that we may uncover signs of microbial life in the past or present on planets and moons closer to us. Mars, with its ancient river valleys and lake beds, has long been a leading candidate for potential life. However, Mars is not the only planet with potential. Jupiter's moon Europa stands out as an intriguing candidate in the search for extraterrestrial life. This icy world has a diameter slightly smaller than Earth's moon, measuring about 3,100 kilometers, 1,900 miles, and orbits Jupiter at a distance of about 628 million kilometers, 390 million miles from Earth. Beneath its icy crust, Europa is believed to harbor a vast ocean of liquid water, potentially double the volume of all the oceans on Earth, making it an ideal target for astrobiological studies. The upcoming Europa Clipper mission, expected to launch in the coming years, aims to unravel the mysteries of this frigid moon. Its main scientific objective is to determine whether the subsurface ocean of Europa could provide the conditions necessary for life. By conducting detailed surveys of Europa's ice shell and underlying ocean, this mission seeks to assess the moon's habitability, examining its composition, geology, and the potential presence of plumes that could provide direct samples of the subsurface ocean. However, exploring Europa is fraught with challenges, not the least of which is the moon's harsh radiation environment. This radiation could damage or destroy an automated landing device within a few hours to days, even with robust protective layers, making the prospect of crewed exploration with current technology a daunting target. With our current technology, a crewed mission to Europa would be nearly impossible, not only due to the vast distance, but also because of the lethal radiation environment. This radiation poses serious risks to any crew daring to venture to Europa. So if the search for life in our solar system faces such significant challenges, how can we dare to dream of exploring the stars in our galaxy? Here are two solutions to this problem. The first solution involves designing and building a generational spacecraft, a type of spaceship that would move at sublight speeds. Since such a ship could take hundreds to thousands of years to reach the nearest stars, the initial occupants would age and pass away, leaving their descendants to continue the journey. As you can imagine, there are some issues with this solution. If such a spacecraft takes multiple generations to reach its destination, it is highly likely that more advanced technologies could be developed on Earth during the journey. These new technologies could render the ship obsolete or even allow faster spacecraft to reach the destination before the generational ship arrives. This paradox raises questions about the viability and effectiveness of generational spacecraft. Therefore, we turn to the second solution, improving propulsion systems. NASA has contracted Lockheed Martin to design, build and test a nuclear-powered rocket for space travel. This technology could shorten the travel time for a crewed mission to Mars from 7 months to just 45 days. A nuclear fission reactor would power the rocket's engine, allowing the spacecraft to achieve a maximum speed of about 22 kilometers per second. However, some designs propose even higher speeds. For example, a design utilizing magnetic fields to expel hot gases from the engine could theoretically reach speeds of up to 123,000 miles per hour, or 197,950 kilometers per hour, or nearly 55 kilometers per second. But even with such unprecedented speeds, the time for a nuclear-powered rocket to reach Alpha Centauri would be around 26,000 years. As you can see, the issue with space is its vastness. However, in the concept of a nuclear pulse propulsion engine, it is proposed that a spacecraft could achieve speeds of around 13,411 kilometers per second, equivalent to about 4.5% of the speed of light. This theoretically allows a spacecraft to reach the nearby star Alpha Centauri within 100 years. There are also theoretical concepts for spacecraft that could achieve speeds of up to 10% of the speed of light. One such concept involves using solar sails. Another project, known as Breakthrough Starshot, aims to develop a nanocraft capable of moving at 20% of the speed of light. This project proposes using lasers to propel a small spacecraft to the nearest star system, Alpha Centauri. However, this concept faces many challenges, such as maintaining the integrity of electronic components in the harsh conditions of space over extended periods. But for now, at least theoretically, this project remains our best chance of reaching the stars. This is a project of breakthrough initiatives aimed at developing a fleet of experimental light sail ships called Starship, capable of making the journey to the Alpha Centauri system within 20 years. If we can devise solutions to the challenges that this project faces, the possibility of reaching and exploring intelligent life on other planets will become closer to us than ever. While we may not yet have found any evidence of life beyond Earth, advancements in technology and our understanding of the universe could bring this into reality in the near future. As we continue to explore, one day we may not only discover life on other planets, but also interact with their inhabitants, opening a new chapter in the story of life in the universe.